Welcome back to our lessons on Chapter 5. 5.2 discusses the power rules. Example 1, the power of a power rule. If you ever have an exponent, a base, and its exponent raised to another exponent, there is a simple shortcut for you to find out what the simplified answer is going to be. If you ever have b to the x raised to the y, it means b to the x times b to the x times b to the x times b to the x y number of times. Now, once the dust settles and you take a look and try to reconcile what that's going to simplify to, it's going to eventually simplify to just b to the x times y. So if you ever have a power raised to a power, what you do with these two powers here is you multiply them. For instance, simplify 2 to the third raised to the fourth. Some of y'all are just like, Mister, can I make this an 8 and take the 8 to the fourth? Yeah, that's going to get you there too. It really will. But we're trying to see if you understand what these do right here. Maybe that's not a 2, maybe it's an x, and then you can't do that. So what we're going to do with this 3 and the 4 is we're going to multiply them together. 3 times 4 is 12, and 2 raised to the 12th power is 4,096. On a test, just to clarify, I want to make sure that I see at least this step here. If this was the problem, then go at least to this step here before you go to that step there. What I'm trying to do is to deter or stop students from just punching this in a calculator. I don't care if your calculator knows what the answer is. I care if you know how to work the process to get that. Anybody, we can train the youngest of math kids to do this in a calculator. Parentheses, it's just copy onto a calculator keyboard. Parentheses 2, caret 3, close, caret 4. Now what we want you to do is understand the meaning behind it. Let's take a look at example 1b. X squared raised to the negative 6th. Let's multiply those two together. That's going to be x to the negative 12th. Remember to always simplify and never leave a negative exponent in your answer unless it's a scientific notation. This ain't sine notes, so this is going to be equal to 1 over x to the 12th power. Number 1c. 3 times the quantity y to the negative third raised to the negative second, all that times y to the negative fifth. Yesterday I had mentioned first step is to get rid of negatives. Well, here, watch what happens if we do this. A negative times a negative is a positive. So this actually becomes 3y to the 6th times y to the negative 5th. Remember the product rule from yesterday says add your powers. You'd be like, Mister, don't you put that? No, just add your powers. Yeah, you can do it the other way, but this is the quickest way. 6 plus negative 5 is 1. Our final answer is 3y to the first, or simply 3y. And let's see what kind of mess we have here. When we raise this to a power, raising a power to a power, exponentiating an exponential, we multiply those. That's going to give us x to the negative 2 divided by x to the negative 9. Those negatives are bothering me, so I'm going to flip-flop bottom to top. I'm going to move this from the attic to the basement. It's going to become x to the positive 2 on bottom. I'm going to move this from the basement to the attic. It's going to become x to the positive 9 on top. Now we're going to go ahead and simplify this. 9 minus 2 is 7. The x's do stay on top because there's more of them on top. Final answer, x to the 7th power. All right, make sure I'm still in frame here. All right. Example 2, the power of a product rule. If we're multiplying two different things inside a quantity and we're raising that to a power, that's the same thing. I would like to compare it to distribution, except it's entirely uniquely in its own right. It has its own characteristics. All I can say, we're not distributing it like we do, because distribution actually literally means multiply this times this times this. What we're doing is exponentiating. We're putting the exponent on both terms inside of there. This is the same thing as b to the x times c to the x. So look at what we have here. This is the number one mistake kids make. They know to multiply this. They get that part right. They say x to the 8th, but then they just bring over this -3 nonchalantly, kind of lackadaisically. That also, this 2 not only belongs on the x, but it also belongs on the -3. What's a -3 times a -3? It's a +9. Same thing here. Just a quick intermediate step to show you what I skipped here. I forgot to show you, or I just chose not to show you the -3 squared. This is going to be the same thing as -2 cubed times a cubed. A -2 times a -2 times a -2 is -8a cubed. All right, let's see what we have here. Yeah, let's try it. I'm going to go ahead and exponentiate everything, including the 3. And that's going to give me 3 to the -2 times x to the +4 times y to the -6. Since I do have some negative fractions, and this is not scientific notation, I am going to have to clean that up. This goes downstairs. It becomes 3 to the +2, or 9. X to the 4th stays on top. And y to the 6th moves downstairs as well. So it's pretty straightforward, pretty simple. Let's take a look at the power of a quotient rule. Very similar to the power of a product rule. This x belongs not just to the top, but to the bottom term as well. So if you have quantity b over c all raised to the x, that's the same as b to the x divided by c to the x. Let's try it here. Pretty straightforward. That's going to be x to the 3rd over 2 to the 3rd, or x to the 3rd over 8. Here, let's see what mess we got going on. This is going to be -2 cubed, x to the 9th, multiply 3 times 3, over 3 cubed, y to the 6th. 2 times 3 is 6. Let's clean up these front two coefficients. -2 times -2 times -2 is already established to be a -8, x to the 9th, all over 3 times 3 times 3 is 27, y to the 6th. All right. Our last example on this side, a negative exponent on a fraction. These are actually my favorite. Give me one sec. This is something I totally want you to memorize what to do. If you ever have a negative on a fraction, then do this. Reciprocate or flip your fraction around. Just flip it around. Here's where it gets confusing. Some of y'all are going to think, hey, I'm going to move this to the bottom and make it a positive. Don't do that. Don't do that. Do this first. Literally, you know what? I need the actual example over here. I don't know why I don't have it. If you ever have a over b to the -x, flip your fraction, b over a, and make it go to the, raise it to the +x. If you flip that fraction around, then that exponent has to change signs. So I'm going to flip this fraction around. I'm going to make it 2 cubed over x to the -2 raised to the 1st power. And now it's time to clean this up. 2 cubed is 8. X to the -2 on bottom becomes x to the +2 on top. Try it again. Flip your fraction. 3/4 becomes 4/3. And change the sign of your exponent. -3 becomes +3. 4 times 4 times 4 is 64. 3 times 3 times 3 is 27. 64/27 is our answer there. Flip your fractions. 4x cubed over -3, now squared. All right, that's going to be 4 times 4 is 16. X cubed squared is x to the 6th. And -3 times -3 is +9. I quickly know that's my answer, and I quickly know that it's not going to simplify anymore, because if it would have simplified in here. The 4 over -3 would have simplified, and it didn't. So it doesn't. So let's move it on. Last problem. Let's make this 3 over -2y cubed. See, I didn't do anything but reciprocate. Flip, flop, bottom to top. Then I changed my outside exponential from a negative to a positive. Let's see if we know what this is. We already know 3 cubed is 27. -2 cubed is -8. And y cubed cubed is y to the 9th. It's that easy, guys. All right, what else we got going on here? Give you a last second on that. Make sure I'm back in the frame. Let's see. All right, that looks good. A summary of all 8 exponential rules that we learned both yesterday and today. B to the negative x is the same as 1 over b to the positive x. B to the 0 is equal to 1 as long as b itself is not equal to 0. B to the x times b to the y is equal to b to the x plus y power. B to the x divided by b to the y is equal to b to the x minus y power. Again, as long as b is not equal to 0, because you can never have a 0 on the bottom. Let's get into today's rules. B to the x all raised to the y is equal to b to the x times y. B to the x, b times c all raised to the x is equal to b to the x c to the x. B over c all raised to the x is equal to b to the x over c to the x, as long as c is not equal to 0. And I threw this one in there myself. B over c all raised to the negative x is the same thing as c over b all raised to the positive x. The negative x becomes positive and the fraction gets reciprocated. Now, I want to throw a little extra one in here. It's kind of like the b to the 0. I want you to remember b to the 0 equals 1 as long as b is not 0. So what if I have 0 to the 0? If I have 0 to the 0 power, 0 raised to the 0 power, that is undefined from yesterday. We talked about this meant this base divided by itself, just like this base divided by itself. Any number divided by itself is 1, except for 0. 0 divided by itself, 0 divided by 0 is undefined. All right, let's talk about a money problem. Compound interest formula. We're going to be using this in this chapter. You're going to be doing a project this trimester. I want to give it to you early. We'll talk about it a little bit more next week. And then you'll have the rest of the trimester to get that project into me. It's a financial retirement project. It's one of the best things you'll do in this class. The compound interest formula states that A equals P times the quantity 1 plus R all over N. Now, the way it's set up right now is for any type of compound interest that's compounded annually. That means once every year. There's a little bit more to this formula, like this is actually an R divided by N, and this is actually an N times T. But in this case, I actually want to make a tiniest of corrections. I want to change that N to a T. This should be the letter T. And let's talk about what each and every one of these letters stands for. This first variable, A, stands for the amount in the account. After a certain time period, if you put money into any type of savings account or any account that earns you interest over a periodic a periodic cycle, then you should have and you will have more money than what you started with. What does P stand for? P is your principal. That's going to be your original deposit. How much you put in there to begin with. Everybody should know that R is an interest rate. While T is time in years. All right, so watch how easy, color coordinated, anybody should be able to get this problem. What we'd like to do is say this. Here's what the question asks. Actually, it's a little story I got to tell you. Here's what happened way back in the year 1926. Your great-grandparents, your G-G-Ma and your G-Pop, G-G-Pa, your great-grandma and your great-grandpa, they came across $100. They took all their money, all their savings, all the money they got for their wedding, all the money that they had saved up getting, ready to start their lives together. And they took $100 of that. It took them a long time to save that $100, but they took that $100 and they said, we want our great-granddaughter or we want our great-grandson to be able to benefit from our intelligence and our brains and our savings. They're going to benefit from our money and time. So in 1926, they put $100 into an account that was earning 13% interest that was compounded annually. So here our interest rate is 0.13. Our principal is $100. And our time is going to be calculated by saying time, what is this year? 2021 minus 1926. That gives us a nice number of 95 years. I should have been 94 years, but we'll leave it in there an extra year. I'll need to change the dates. Every year I got to update this. But we're okay. You're like, what are you talking about? Yeah, I like the number 94. 95 will give us more money, but I just like that 94. So we'd like to know if great-grandma and great-grandpa invested $100 into an account for you in 1926, blah, blah, blah. You know the rest over here. How much will you have today? And by today, I mean the year 2021. If you were to go cash that money out right now, how much money would you have? Now, you're going to have to pardon me for a second. I do not have my calculator here with me. I need to see if I can get one real quick. Here's what the setup is. How much are we going to have after 95 years if we started with $100 and we're going to multiply that times 1 plus, what was that old interest rate? 13%. Man, that's a very, very generous and healthy interest rate. And we leave it in the bank for 95 years, or we left their money in the bank. And the deal with this is, it was kind of a secret. You didn't even know about this, and your parents didn't know about it. Your grandparents didn't know about this. It was just a letter they found all of a sudden. They found it while they were cleaning out their house over Christmas, putting the Christmas decorations back. They said, hey man, look at this. Can you imagine this? They saw some information. They sought some help. They got a lawyer to help them out. And that money, you're going to see the power of exponents. And I use that, pun intended. Exponential powers are very powerful. All right, let me go to my computer real quick. 100 times the quantity 1.13. I went ahead and added that in my head. That was easy enough. All of that raised to the 95th power. Year after year after year after year for 95 years straight, it sat in there. The $100 did. Oh, I don't know if I could show you. I would like to show you the computer screen. I just don't know if I'm on screen there. But I did 100. Let's see, am I anywhere close? Yeah. 100 times 1.13 raised to the 95th power. Because I know some of you ain't going to believe this. 1, 2, 3, comma, 1, 2, 3, comma. 11,026,866.86. Let me write that down. So this amount will be rounded off to $11,026,866.86. So your great grandparents left you $11,026,866.86. You will be free to share that with your math teacher. Yeah, we would like, I'd be happy with 1% of that. I'll take $1 million. Oops, that's 10% of it. I would take a nice $110,000 just for kind of teaching you this. That'd be a nice, generous offer. Anyway, I hope y'all have a good weekend. Please take care of yourself and each other, as old Lester Holt says. Be safe, make good choices. I will see you all on Monday.